Today we will be learning about Newton's laws of motion. First of all, who was Isaac Newton? He was the son of two peasants born on December 25, 1642 of the Gregorian calendar in Lincolnshire, England. His father had deceased before he was born, and when he turned 3, his mother married a priest, moved in with him, and left Isaac to the care of his grandmother. His stepfather died and his mother was left with a huge inheritance and 3 kids. He enlisted at Trinity College at the University of Cambridge in 1661 and received a Bachelor of Arts in 1665. In 1666, in between a terrible plague and the fire in London, Newton made his greatest discoveries in the field of optics, calculus, and physics. He died on March 20th, 1727. And now, down to business.
We're going to explain how inertia works. Right now, we're going in a straight line with the car, and our bodies are driving along with the car. But as we turn right, our bodies will want to go left to stay in the same position as they were. And when I turn to the right, you'll see what I mean.
Oh no!
See?
Ouch.
Inertia was what made them move to the left.
Hi, this is Physics with Philip Zimbardo, and right now I'm going to explain the car experiment. When we were at the car, we were driving in a straight line, right here. And there were 2 people at the back driving also in a straight line along the car. When I turned to the right, the people in the car were still going in a straight line. So when I turned to the right, they tended to maintain their actual position, and that's why they moved to the left, because the car, their inertia was making them go in the same line they were going.
In this other case, our object is stationary, and when a force is applied to it, its velocity doesn't change, because the force applied to it is much smaller than the object's inertia.
Hi, this is Learning Physics with Philip Zimbardo. Right now we're going to talk about Newton's second law, which states that force causes acceleration, as you can see in the next formula. An acceleration is proportional to force and is inversely proportional to mass. What I mean, I'm going to explain it with the next experiment about a bowling ball and a soccer ball. If we have a big bowling ball with a bigger mass, the force we need to move it is going to be bigger, and the acceleration is going to be smaller because the mass is a lot larger. We need a lot more force to move it. But with the soccer ball, acceleration can be bigger, applying the same force because we have a smaller mass.
Yeah. In this case, we apply a forward force to the disc, but we have a force acting in the opposite direction, called friction. In this example, friction is greater than the force we applied to the disc, so the disc slows down quickly. In this other example, the air that is shoot out the holes reduces friction, so when we apply the same force on the disc, the friction and the force will be the same. So our disc will move at a constant velocity. Take a look. Exactly the same.
Hi, this is Philip Zimbardo, and we're going to explain the Newton's third law. The third law states that every action has a reaction. In other words, when the first object applies a force to the second object, that second object is applying also a force to that third object. For example, right now I'm applying force to the wall, but the wall is also applying force to me. That's why I'm not falling. Also, I can explain it with the next experiment. If we have two pool balls traveling at a constant velocity, so when they crash, both balls are going to shoot to the sides.